Hi everyone, welcome to week 1 of virtual learning. This is our first science lesson of the week. And as you see in the assignment, you should see this first. It's called Getting Ready to Read, How Big is Big and How Far is Far. So before you listen to the read aloud and you follow along to that, you are going to fill this out first. Simply, if you agree with something, you put an A on the line. So just put an A just like that. If you disagree with something, you would put a D on the line. It's just to see kind of what you know or what you think you know before we get into our read aloud and finding out more information. So once again, fill this out first before listening to the read aloud. The read aloud is attached. There is a link there for you, and the PDF version is also there for you. So let's get started with that. Here. Okay. So this is called How Big is Big and How Far is Far. All right, how big is big? Everyone knows whales are big. A beluga whale is longer than a car and weighs about 1,000 kilograms. That's more than 2,000 pounds. That's big, or is it? Look at a blue whale, which is the biggest animal that has ever lived on Earth. If you lined up 6 cars, they would be about as long as a blue whale. So think about that, 6 cars lined up. That's pretty big. A blue whale can weigh can weigh up to 200 times more than a beluga whale. So we talked up here how a beluga whale is 2,000 pounds, and now we're talking about the blue whale. So we're comparing those two whales. So if you see here, it's one blue whale is 1, 2, 3, 4, 5, 6 cars, and 1, 2, 3, 4, 5 beluga whales. What's big? It depends. A beluga whale is big, but it would take about 5 of them lined up to be as long as a blue whale. Whether you can call something big depends on what you're comparing it to. It's the same in space. We're going to talk about what we think is big in space. For example, think about how big the moon is. It's hard to tell what size the moon is when you look at it in the sky. But if you went to the moon and stood on the surface, it would seem huge. A walk around the moon would be more than 10,000 kilometers, which is about 6,000 miles long, which is about the distance from New York to California and back. Astronauts who visited the moon need this rover to help them travel to places they want to study because it was too far to walk. At the same time, the moon is small, much smaller than Earth. In fact, you need to line up 4 moons side by side to be about as wide as the Earth. The moon is much smaller than Earth. And there's a picture here comparing the moon. So now when we're comparing the moon to Earth, in this case, the moon now looks smaller. Imagine 2 kids are arguing about the size of Earth. And one kid says the Earth is big, while the other says the Earth is small. Who is right? Is Earth big or small? Actually, they are both right because it depends on what you're comparing Earth to. So Earth is huge compared to the blue whale, a house, a city, or even a whole country. There are about 200 different countries on Earth. There are thousands of cities on Earth. It would take more than 1 million blue whales lined up to stretch around the Earth. Look at the data table. This is the data table over here on this page to see the sizes of the planets in our solar system. If you compare Earth to other planets in our solar system, it doesn't seem so big anymore. Is Earth a small planet or a big one? Which planets make Earth look big and which ones make Earth look small? We have pictures here of Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The picture shows the sizes of the planets compared to one another. And up here we have the approximate diameters of each planet. So you can take a moment and look at that as well, comparing the diameters. Okay, Jupiter is the biggest planet in our solar system. Did you guys know that? And its diameter is about 11 times bigger than Earth's. That means if you lined up 11 Earth-sized planets side by side, they would be about as wide as Jupiter. Jupiter really is big, right? It may seem that way, but there's something in our solar system that makes Jupiter actually look even small. So diameter, if you look here, this is a diameter. It's like the width. So 11 Earths make up one diameter of Jupiter. So this is a picture here. Think about this is our sun. And you need 10 Jupiter-sized planets and 110 Earth-sized planets to make up the diameter of our sun. That's right, it's the sun. The sun is so big it makes Jupiter look small, and it makes Earth look tiny. In fact, the sun's diameter is almost 10 times the diameter of Jupiter and about 110 times the diameter of Earth. The sun is the biggest object in our solar system, but our solar system is only a small part of the universe. Is there anything out there that would make the sun look small? When you look out into the sky at night, you may see stars. They look like tiny specks of light, but are they really tiny? Arcturus is one of the brightest stars you can see in the sky on a summer night. If you lined up 25 stars the size of the sun, they would be about as wide as Arcturus, which means Arcturus is definitely big. By now, you probably know that there's always something bigger out there. On winter nights, you can see a bright star called, now I think I'm pronouncing this right because I looked it up, it's called Betelgeuse. Almost like Beetlejuice. You would have to line up 40 stars the size of Arcturus or 1,000 stars the size of the sun to be as wide as Betelgeuse. Is the sun big? As the only star in our solar system, it seems big, but when you find out how big some of the other stars are, the sun doesn't seem so big anymore. Let's look at some data on different star diameters. So we're going to look over here, and if we compare these pictures to Arcturus and our sun. So if you notice, yes, our sun is big in our solar system, but it is small compared to Arcturus. So you can take a moment and look at those diameters in kilometers. An artist created this image showing what a huge star, Betelgeuse, might look like if you got close to it. If the sun were next to Betelgeuse, it would look like a tiny speck. We've discovered that things in space are very big. Things in space are also very far apart. But how far is far? So part of our book was how big is big, and now we're focusing on how far is far. Who lives close to your school and who lives far away? In places where people's homes are close together, many students live close to the school, sometimes just a block or two away. I'm sure some of you guys can walk. If you're a walker, you can walk to school, or some people might have to take the bus because they're a little further. In these places, people might say students live far from school if they have to walk more than a half an hour to get there. It's pretty far. In places where people's homes are further apart, some students might have a long ride in the car or bus to get to school, and a half an hour walk to school would not seem that far at all. Do you live close to your school or far away? That depends on what you're comparing the distance to, just like how we were comparing how big is big and comparing things like the sun. We're now talking about distance. If a car could drive from Earth to the sun, listen to this, it would take more than 160 years without ever stopping to get there. Think about that. That's longer than anyone can live, 160 years. Are we there yet? Distance in space depends on what you're comparing. Earth is about 150 million kilometers, which is 93 million miles away from the sun. That's far. It makes sense to say Earth is far away from the sun, or does it? So if you look here, we have Saturn, Jupiter, Mercury, Venus, the sun, Earth, and Mars. The diagram on these pages is made to help you compare the distance between the planets and the sun. It does not show the sizes of the sun and the planets correctly. So when you're looking at this photo, it's only showing the distance. It is not showing the sizes. It's not comparing sizes, it's comparing distance. If it did, the planets would be too small to see on the page. So we noticed maybe you can say these are a little bit closer together and these are a little bit further apart. As you may guess, you can say Earth is close to the sun, and you can say Earth is far from the sun. Either way, you're right. Compared to some of the other planets, Earth is very close to the sun. So I'm gonna go back up there and show you. So here's our sun and Earth, we're pretty close to the sun, but Mercury seems even closer.
The farthest planet is more than 4 billion kilometers away from the sun. That's one distance we can definitely say is far, can't we? So here again, we have the distance from the sun in kilometers and the planet. So you can look at that too. Is the sun near Earth or far away? From our perspective, the sun is far from Earth, but is extremely close for a star. Compared to the sun, the other stars are much farther away. Besides the sun, the next closest star is called Proxima Centauri. It would be a very long ride to get to Proxima Centauri, even at the fastest spacecraft that exists. The fastest spacecraft that has ever been launched travels about 50,000 kilometers, which is 31,000 miles every hour. Even at that speed, it would take almost 90,000 years to get to Proxima Centauri. It's crazy. The fastest spacecraft ever launched is called New Horizons. It does not carry people. There is something that travels much faster than the spacecraft: light. In 1 year, light travels about 10 trillion kilometers, which is 6 trillion miles. That is the distance astronomers call a light year. Some of you might be nodding your head and you know what a light year is. Awesome. A light year is not a long time. It is a huge distance. So light year is not time, like we think of our year as time. Light year is actually distance. It takes about 4 years for light to travel from Proxima Centauri to Earth. So we can say that Proxima Centauri is 4 light years away. A light year is such a long distance that the distance from Earth to the sun is only a tiny fraction of a light year. Here's a data table showing the distance from Earth to a few different stars. So once again, these are data tables, and you do have this PDF version that you can look at on your own after this, and you can refer back to this if you would like. So in 4 light years, Earth to Proxima Centauri, it takes 4 light years to travel that far. It is hard to visualize how far away stars are. A long time ago, people thought that all stars were the same distance from Earth. They thought the stars were attached to an enormous sphere that surrounded Earth like a giant shell, and the stars on the sphere surrounded Earth in all directions. They thought the stars were stuck to the sphere and never changed their positions on the sphere. The diagram shows the way people once visualized the stars. People used the image that all stars were the same distance from Earth. People will write that all stars are around the Earth in every direction. You can imagine why they thought that all the stars were stuck to something. After all, we always see stars in the same arrangement in the sky. However, there is no shell around Earth. All the stars are not all the same distance around Earth, Even stars that look close to each other can be different distance from Earth. For example, the 3 stars that people call Orion's belt look like they're lined up side by side. But if you saw them from somewhere else in space, you would see that they are spread far apart, and each of the 3 stars is a different distance from Earth. And you can see that over here. They look like they're next to each other, but they actually aren't. And this is the distance of stars in the Orion's belt. And if you look here, 910 light years, 820 light years, 1,340 light years. In this book, you have seen a diagram representing distances in our solar system. You can use the diagram on page 16 and 17, and in order to know which page is which, on the bottom right here, you will see the page number. You can use those pages 16 and 17 to compare how far Earth and other planets are from the sun. You have also seen a diagram representing distances beyond the solar system. You can use a diagram on page 19 to visualize the distance between the Earth and the nearest star besides the sun. It might seem like a good idea to end the book with a diagram comparing distances inside the solar system and beyond the solar system at the same time, but there's a problem with trying to do that. The distance between Earth and the sun is 150 million kilometers. If we make a diagram that represents distance as 1 centimeter, how far away on the page do we have to put a picture of Proxima Centauri? Think about that. We would have to put Proxima Centauri 2.7 kilometers away. 2.7 we also say is 2 7/10, and about 1.5, which is 1 5/10 miles Proxima Centauri is about 270,000 times farther away from Earth than the sun is. There is no way to fit a diagram comparing those distances in any book that has ever existed. The diagram and the book would have to be much too big. Are Earth and the sun close together? Is Earth small? Are the stars far away? Is there anything even farther than the stars? Big or small, close together or far apart, whichever you think about it, it makes sense. Pretty good book. At the end here, we do have our glossary of all the terms that were discussed, all the important terms and their definitions. This is always good to look at. And that's it. So again, after you're done with this, there are a few questions to answer after on a Google form. And you do have this PDF and the link to this if you want to refer back to this, if you need to, or if you just want to reread it. All right, remember this is due Friday. Have fun.